Hi guys, this is Engineer HB again and welcome back to Derive. So medyo matagal tayong natenga uli due to some accident. Pero I hope na tuloy-tuloy na ang pag-upload natin. Of course, especially matapos na itong MD. And I will continue uploading also on the MD and rather mathematics and pipe. Pero tapusin na muna natin ito. So our topic for today is Chapter 12 breaks. 6 to 7 chapters siguro matatapos na natin tong MD. So this is a part past board exam problems. And as usual, before we proceed to questions, review muna natin yung formulas. Okay? Ayan. Kuha lang ako ng ink. So brakes, ano nga ba ang brakes? This is a device which is used to regulate or stop the motion of a body. So dalawa ang keyword is to regulate or stop the motion of body. So if the motion is involved, of course, nandyan yung speed, nandyan yung torque, nandyan yung force, of course, nandyan din yung power, so on and so forth. So there are two types of brakes. We have the band brakes and the block brakes. So under band brake, we have the simple and differential, and later we're going to see what's the difference between those two. And the block brakes, we have the single and the double. In order for us to be the master of this topic, of course, we should start and familiarize ourselves into these band brakes before we proceed to block brakes. So this topic of brakes has a combination of engineering mechanics kasi dyan papasok uli yung ating pre-body diagram and syempre machine design principles. So we have the simple band brake here. Simple band brake has one end of the band is fixed to the pivot support. So our pivot support is here at point O. So this is our band. Okay, so ibig sabihin one end of the band. So isang band daw ay naka-fix sa pivot support. So this is small N represents the RPM. This D represents the drum diameter. Of course, we have our drum here. And this FB represents the braking force. Why? Consider we have a clockwise motion here. Of course, we have tensions on the band. So this is our tight side tension given this clockwise approach. And this is our loose side tension. Of course, if we have a tension back there, there should be a counter force, and that is the braking force. Okay. So parang isipin mo lang these two bands or these two tensions is the resultant force at ang kailangan kumontra is this braking force. Okay? So if we have force here, kunyari F1 to, and this is F2, at kapag counterclockwise naman, this should be your F1 kasi this, that will be your tight side tension. So we have the band tension ratio of F1 over F2 is equal to EF theta. And remember guys that F1 should be always bigger than F2 kasi EF theta is always greater than 1. So what is that theta? So that theta is your contact angle here, and F of course ang walang kamatayang coefficient of friction. And this kind of setup F1 over F2 is equal to EF theta is familiar to us way back on our shafting design and other topics. So kung paano i-compute yan, alam na natin yan, that will be dimensionless. And of course, if we have tensions here, we have also the friction torque that is equal to force times radius or force times diameter over 2. And that force will be the difference of the two tensions, which is the tight side and the loose side tension. So lagay natin may torque dito. Yeah. So below here is the pre-body diagram. As I said earlier, magkakaroon tayo ng mechanics na approach dito. And kailangan natin ng knowledge way back our engineering mechanics. Pero basic lang naman ito. So this pre-body diagram is para sa clockwise approach. Kaya nga ito ang F1 and this is F2. So sabihin natin clockwise approach. Ang ating braking force here is, so pwede tayong mag-summation of moment at this point O. That will be the pivot. So summation of moment about O is 0. that will be F2 times A is equal to FB times length. F2 times A and FB times length. So how about the counterclockwise approach? What is our braking force? So kagaya ng uli, summation of moment is equal to 0. So kapag counterclockwise approach naman, this will become your F2 guys. And this will become your F1. Why? Kasi ito na yung tight side tension mo. Kasi nga counterclockwise na yung approach. So ito na yung band na pinaka sasalo ng amount ng force na malaki. So meaning, ang F2 ang mapupunta sa O. So that will become F1 multiplied by A is equal to FB multiplied by the length. Okay, so that will be the formula for the braking force. And syempre, kung may tension ratio, may force ka, may friction torque ka, hindi mawawala si power, and that is equal to torque multiplied by speed divided by some constant. Depende kung horsepower or kilowatts ang hinahanap. So, alam na natin yan. Na-review na natin yan way back. Siguro, may mga 4 videos na nag-contain ng formula ng power. And hindi ko na uulitin. Mamaya na lang sa mga questions. And we have also the differential band brake. No end of the band is fixed to the pivot support, unlike the simple band brake. Yung isang band nasa pivot support, and this differential band brake has no band that is pivoted or attached to a pivot. So kagaya ng ganyan, as you can see, medyo lumayo lang yung point O, pero ito yung point O talaga. So ito yung tension band mo, and this is your band. So nakakabit siya sa lever, pero walang nakakabit sa point O or your pivot support. And of course, may speed ka pa rin dyan, dyan pa rin diameter, dyan pa rin braking force, and so on and so forth. So if the approach is counterclockwise, our formula for that is FB is equal to F1B minus F2A over L. And if the approach is clockwise, so magkakabaliktad lang, F2B ang mauna minus F1A times length. So para hindi kayo mag-memorize ng ganito guys, I suggest na i-drawing nyo na lang and derive. That's why my channel is derive. So joke lang. So I mean, mas mainam pa rin talaga para hindi kayo malito is to derive this formula using engineering mechanics. So, tara, pakita natin. So, kunyari yan. Teka, paling. Teka. Sumado kasi ako, guys. Yan. Kunyari yan yung length. And this is your A. And this is your B. Yan yung A. So, this is your length. Palabasin natin yung clockwise na lang. And guys, nga pala, pag nagsasagot kayo ng questions about brakes and there are no approach that is that are stated, so always assume na clockwise lagi. So this is a clockwise direction, meaning ganito ang ikot. So ibig sabihin so ito lagi ang F1 mo, so this one, and this is your F2. And this is your braking force. Okay. So this is your F1 and this is your F2. Okay. So kung clockwise ang approach, palabasin natin tong formula na ito. So summation of moment tayo about point O. Ito yung point O. Summation of moment about point O if clockwise approach. So that will become, so si F1. Sorry. This should not be the F1. Sorry guys. Dito pala ang F1. Okay, so from the pre-body diagram, ang F1 natin is summation of moment about point O. So the perpendicular distance is the letter A. So plus FB kasi pareha silang paganon sa point O. Okay? So that will become, so tama. Ayan. Ayan. Tapos, ayan. So dito, isang technique yan para malaman mo sino magkaka-partner sa clockwise and the counterclockwise. So that will become F1 multiplied by A plus FB multiplied by the length or L is equal to F2 multiplied by B. So itira mo natin si FB here multiplied by length is equal to F2 times B minus F1 A. Ayan. So our FB should be cancel here and mapupunta siya dito. And that will be the same on this formula. Okay, so I advise na kapag lumabas ang differential band break na problem, mas mainam yung pre-body diagram, guys. So, okay. So, how about other formulas naman aside from the pre-body diagrams? So, of course, we have the maximum tensile stress in the band, and that will be always the F1 ang magiging involved dyan. Kasi lagi yan na mataas sa two tensions. So, that will become ST, or yung maximum tensile stress is equal to F1 over BT, and the BT is this width times the thickness, rather B, and tama, B thickness. So, wag yan dito. So, this is your thickness. So, that was width of the band thickness. Mamaya na lang siguro sa problem, isabay yung unit analysis. And of course, we have the maximum lining pressure between band and drum. So, syempre may lining pressure yan between sa band tsaka sa drum. Inulit ko lang yung sinabi ko. So, that was the Pmax, and the maximum lining pressure is equal to 2F1 over D times B. Or pwede rin F1 over radius times width. Pero pwede rin 2F1 over dB kasi laging given ay D is equal to drum diameter. So second type of the brake is the block brakes. Simulan natin sa single block brake. So dito naman guys, magkakaroon ng itong part na to, yung nakaano yung letter R, yan din yung braking force pero iibay natin yung letter, so that will become letter R. Same scenario sa simple and differential. Pagkaiba lang is meron kang itong tawag dito. Yan, meron kang block. Yang yan. Yeah, yan yung block niya. And of course, baguhin ko lang yung ink. Ayan. So of course, this is your block. Kasi nga block brake. And our braking force will become letter R. So ito siya. Ayan. So tatlo pa rin yung magiging distance na involved. So that will become A, B, and C. So sa previous slide, we have the A, B, and L. So ito ay A, B, and C. Kasi meron na siyang block na nagdagan nito. And of course, we have the contact angle of 2 theta. Sa problem guys, pag sinabing a block brake has a contact angle of 90 degrees. So ibig sabihin nun, ang theta is 45 degrees. Okay? Of course, this D represents the drum diameter. Of course, N is your RPM. And yun lang talaga nadagdag guys. So ito pala, dito pala natin makita yung madadagdag guys. So the F and P. Kanina meron tayong F1 and F2, but in this problem, wala na kasi tayong band. So ang forces na lang is FP. Ano yung F na yun? So F is our frictional force at the drum or block, and of course, this P is the normal force. So bakit nagkaroon ng normal force? Kasi nga, si drum mo, which is here, ay nagkaroon ng contact sa block. And syempre, may kiskisang magaganap dyan. So, meron siyang normal force, and of course, meron din siyang frictional force. And for the clockwise approach, so baguhin ko na yung dilaw. Ayun po lang ink. So, magiging dilaw na para mas makita natin maigi. So our clockwise approach, magkakaroon ng formula na R is equal to PA or normal force times A minus friction times C and all over A plus B. So this, dito naman sa counterclockwise, so yung minus mo dito naging plus lang. If you want to memorize this, ito lang tandaan mo, for clockwise minus to. Pag sa counterclockwise naman, gagawin mo lang plus. And I'd advise na wag niyong kabisaduhin ito. And go ahead if you want, pero mas mainam pa rin kung alam niyo saan galing. So take the free body diagram of this and makukuha niyo yung result na to. I'm not going to show anymore that. Medyo kain ng oras yun. Of course, kung may single, mamaya pala. Okay, so single block brake. Meron tayong formulang i-introduce and that will be the F, which is the frictional force at the drum of the block. Okay. So guys, para matandaan nyo itong formula na to, remember sa engineering mechanics natin, we have the F or the frictional force is equal to U times the N. We all know that U is the coefficient of friction and N is the normal force. So ang N natin na normal force, lumalabas, ito yung P. And yung U natin na coefficient of friction, itong maliit na F. And ito ang frictional force natin. Madali yung tandaan, pero mahirap tandaan dyan is this factor. So saan lumabas yung factor na to? So it is derived from the scenario that the drum is connected to the block brake and it is composed of contact angles such as this. Yung 2 theta na yan. So meron tayong F is equal to UN multiplied by some other factor which is this 4 sine theta over 2 theta plus sine 2 theta. As I mentioned earlier, this theta karaniwang ginibigay sa problem is naka 2 theta na. Pag sinabing the block brake sa contact angle of 100 degrees or 90 degrees, so that will become 45, the theta should be 45 or 50 degrees. So insert mo lang siya dyan. And ito ay magiging radians. At ito naman, of course, ay degrees pa rin. So this is degree, and ito radians. So I will show you later paano yun. Of course, we have a torque here, ang walang kamatayang torque. So force times radius or force times diameter over 2. And the power is, of course, yung pa rin, torque times the RPM. Okay, so how about double block brake? So talagang as in yung single block brake, imaginein mo lang, ayan, dinoble lang dito. Okay, so we have the left and right block brake na naka-attach sa drum. And this is the free body diagram. So ibayin natin konti uli ang pula, ang tinta. Of course, this is our drum. So ito yung block natin. Block. So those are the block brakes that are attached to the drum. And of course, you have this left and you have this right. And of course, since naka-attach ang drum to both double block, of course, may nangyayari dyan na normal force and of course, meron niyang friction. So both here and both here. So just put a subscript of left and right. At kapag piniri-body diagram natin, of course, itong mga araw na to ay magbabaligtaran pero parehas lang ang amount niya. Of course, we have this normal force here. And syempre, pag may normal force, may friction force for left. And for right naman is this normal force R and frictional force R. And syempre, same pa rin sa torque ng single block brake. Ang pinagkaiba nga lang, magpa-plus na yung dalawang frictional force kasi meron tayong T is equal to force times diameter over 2. And since this is double block brake, so magkakaroon ka ng FL plus FR. Okay, sabi nga, 2 pairs of forces P and F at each block. Ayan. Thus, the friction torque equation becomes FL is equal to PF for sine theta over 2 theta plus sine 2 theta. Kagaya sa single block brake, F is equal to coefficient of friction times the normal force and of course some factor. So meron tayong 4 sine theta here and 2 theta here which is in radians and sine 2 theta here sa dulo. So ito na lang guys, pakiusap ko sa inyong kabisaduhin because frictional force is always normal force times the coefficient of friction, and in this scenario we have to consider this factor. Okay? So syempre kailangan, engineer, bakit kailangan magkabukod pa yung formula ng left and right? Of course, kasi minsan hindi parehas ang contact angle ng left and right. And minsan maaari ding magkaiba ang coefficient of friction. Pero for some simplification, other questions ay pinagpaparehas na lang. Okay, so let us proceed to the answering questions and don't forget the calculator, guys. Ang sabi, a band brake is to absorb 5 horsepower at 200 RPM. The maximum pressure between the lining drum is 120 psi. The width of the band is 3 inches and the coefficient of friction is 0.15. Find the maximum band tension. The diameter of the drum is 8 inches. So ang hinahanap is the maximum band tension, which is always your F1. So ano-ano ba ang given? Ang given daw is the maximum pressure between the lining drum is 120 psi. So may given tayong horsepower at 200 RPM which can be find the torque. Pero for simplification, lagi natin unahin itong basic na mas madaling hanapin. So Pmax, we all know that is 2F1 over diameter times width. So tingnan nga natin kung parehas given. So Pmax daw is 120 psi. So that will become 120 pounds per square inch is equal to 2 F1 which is diameter. Ang sabi dito 8 inches. At ang width is 3 inches. So everything is complete. Direct sub. Inches squared is cancel. Matitira si pounds. So which is F1 is equal to 120 times 8 times 3 divided 2. So that was 1440. So the answer is letter A, obviously. So don't forget the 2 dito guys kasi may 2880 dyan. Pag di nyo na i-divide ng 2 to, 2880 lalabas sa inyo. So that was 1 point agad na mali. Okay, number 2. A band brake is used to operate on a 600 millimeter diameter drum that is rotating at 200 RPM. The coefficient of friction is 0.25. The brake band has an angle of contact 270 degrees and one end is fastened on the brake arm 120 millimeter from the fixed pin. The straight brake arm is 760 millimeters long rather, haba na and is placed perpendicular to diameter, bisecting the angle of contact. Determine the minimum pull necessary at the end of the brake arm to stop the drum if 34 kilowatts is absorbed. Okay, so how are we going to do this? So ang sabi is to operate on a 600 mm diameter drum. So this is your drum diameter rotating at 200 RPM. So walang sinabi, assume clockwise rotation. So this is your RPM. So the coefficient of friction is 0.25. The brake band has an angle of contact of 270 degrees. Okay. And one end is fastened on the brake arm 120 mm from the fixed pin. So this is your fixed pin and this should be 120. The straight brake arm is 760. So ito yun, dalawa lang naman ang arm. And is placed perpendicular to the diameter, bisecting the angle of contact. Meaning, ito siya. Yan. Right angle sila dyan. And of course, ang sabi, to diameter, bisecting the angle of contact. So this is your angle of contact. And I will create a line that bisect this angle. So that will be this line. Okay. So meaning kung 270 degrees to guys, ibig sabihin tong natitira ditong angle is 360 minus 270, so that will become 90 degrees. And of course, kaya na sinabing may bisector dito, meaning this should become 45 degrees and this should become 45 degrees. So maglagay na rin tayo dito. Okay? So kompleto na ba ang nasulat nating given? So determine the minimum pull, meaning ang FB ang tinutukoy dyan. Necessary at the end of the brake arm to stop the drum if 34 kilowatts is absorbed. Sabi, ang power daw is 34 kilowatt. Determine the minimum pull necessary at the end of the brake arm. So that was your FB. So how are we going to start on this? So paano to guys? So draw the free body diagram muna tayo. So in order for us to get the FB, way back on our previous slide, may mga formulas tayo, and that will involve the two band tensions, which is the F1 and F2. In short, we need to get the F1 and F2 first in order for us to get the FB. So free body diagram. Ayan. So kunyari, ito yung 120. And ito yung 760. Ayan. So, pwede nating sabihin na ito si F1. Ito yung tight side tension kasi ikot natin is clockwise. And this is your F2 at some angle of 45 degrees kasi 45 degrees to guys. Okay. So, ang hinahanap is the minimum braking force. So, pwede na tayong, ito ang point O. So, create muna tayo ng equations, guys. So, in this particular scenario, we can do the summation of moment of O is equal to 0. So, that will become, ang F1 natin ay, tama ba? Ang F1 natin ay ma-disable. Kasi nasa moment o siya, ay nasa point o siya, so that will become F2 so disable ang horizontal ng F2, so that will become sine 45. Sine 45 degrees. Anyway, sine 45 is also equal to cosine 45, pero kapag iba na yung degrees, yari na. So that's why important. Kasi meron ka diyang dalawang component, di ba? Kaya ang sabi ko sa inyo, kailangan ng mechanics dito. So that will come F2y and this is F2x. And since dumaan ang line sa point O, kapag nag-summation of moment ka, wala nang moment ito. So matitira y and that will become sine 45 degrees is equal to F2 sine 45 degrees. Of course, multiplied by 120. Kasi 120 siya, papuntang O, is equal to FB times 760. So that will be our equation 1. Makukuha na sana natin yung FB kung may F2. Pero paano natin makukuha yung F2? So remember na meron tayong formula na F1 over F2 is equal to EF theta. Kulain ko lang F, pangit ang aking sulat. Pangit pa rin pala. So F1 is equal to F1 over F2 is equal to EF theta, and that will become F, which is, ang sabi kanina ay 0.25, and our contact angle is not 45 degrees. Be careful guys, but 270 degrees. Okay? So that was 270. So radians yan guys. So it should be multiplied by pi over 180 degrees. Kasi kapag 180 degrees, convert mo sa radians, so that will be pi. So 0.25 times 270 times pi divided by 180. E mo yun, raised to that answer. So that was 3.248. So meaning our second equation is F1 is equal to 3.248 F2. So makukuha na sana natin guys yung F2 kung may F1. How are we going to get the F1? So remember guys, we have the frictional torque that is equal to T is equal to F1 minus F2 times diameter over 2. So diameter natin is given na, that is 600, but we have no torque. And guys, remember kanina meron tayong power is equal to torque multiplied by the RPM. At meron giving na 34 kilowatts na power. So that will become 34 kilowatts is equal to torque times the RPM of 200. Ito guys. Divided by some constant. Na-review na natin yan dati. That was 9.549 times 10 raised to 6. And ang sagot nating torque dito is in Newton mm. So our torque will be, ang torque natin is 34 times 9.549 times 10 raised to 6 divided by 200. So that will become 1623330 Newton mm. So meron tayong torque, pwede nating i-shoot dito. So that will become 1623330 Newton mm is equal to F1. So pwede nating diretso to guys. 3.248 F2 minus F2 times 600 divide 2. So get the F2 at makukuha mo rin ang F1 mamaya. At makukuha na rin natin ang FB. So ang F2 natin is 3.248 minus 1 muna agad. Okay. Times 600 divide 2. Labas si F2. Tapos divide mo sa torque yung nakuha mong sagot doon. So we're going to have a F2 of 240.7 Newton. And way back here, we have equation 2, we have 3.248 times F2 that is inserted here. So pwede mo na agad multiply by 3.248 yung sagot mong F2. So your F1 is 781.8 Newton. And since wala tayong space, pwede na tayong bumalik sa equation 1. Which is, ang sabi ang F2 mo is 240.7 times sine 45 times 120. Divide mo ng 760. Tama ba? FB. 240.7 times sine 45 times 120. Divide 760. Teka. 1623330. Balik tayo sa torque. Parang ang late ng sagot. 23330. Ah, 2407 to guys. Sorry. Ay. Ang tagal ko rin kasi nawala, no? Medyo nabengko ang ating utak. So, multiply mo muna ng 3.248. So, that will become 7818.2. So, kulang lang talaga ng isang digit. So, ayun. Insert na natin itong F2 lang pala dito sa equation 1. So, that will become 2407.1 times sine 45 times 120 divided 760. So, that was 268.75 newtons. Aba neto, no? Just 1 point lang sa exam. So our braking force applied is, or the minimum pull necessary at the end of the brake arm to stop the drum is 268.75, which is obviously pwede nating i-round off into 269 newtons. Okay, napakahabang number 2, pero good example, guys, for us to be refreshed. And yan, 3. From the above problem, ayan. Yan napapasok yung hindi nasayang yung sinolve mo kanina. Hindi lang siya pang 1 point kasi mayroon siyang consecutive questions. From the above problem, what width of steel band 2.4 mm thick? Lagay na natin dito. is required for the brake if the maximum tensile stress is not to exceed 55 megapascal. So way back on the previous slides, we all know that the maximum tensile stress is equal to F1 all over width times thickness, and we are looking for the width, and we have already the thickness, we have already the maximum tensile stress. Ang kulang lang natin is F1. So balikan lang natin yung previous slide. So our F1 is 7818.2. So ang sabi, 55 Newton over mm squared is equal to 7818.2 newtons divided by B, and thickness is 2.4 mm. Cancel isang mm, cancel ang newton, so matitira mm. So our answer should be in mm, kaya ng nasa choices. 55 times 7818.2 divided by 2.4 by 55, so that will become 59.23 mm. So that, ito yan. Letter A ulit. So what bond thickness in mm is necessary for a 500 millimeter diameter drum if the maximum lining pressure is 0.05 megapascals and the allowable band stress is 4 megapascals. So dalawang megapascal ang given. Isa yung maximum lining pressure at isa yung allowable band stress. So how are we going to get the thickness? So meron dito tayong formula na Pmax is equal to 2F1 over dB, and at the same time we have the maximum tensile stress of F1 over TB naman, thickness times width. So I will replace this as capital D to avoid confusion. So hinahanap is thickness. Makakukuha na ba natin agad yan given the band stress of 4 megapascals? At wala ring given na width, pero hinanap thickness. So this should be question mark and this should be question mark. So barain ko itong question mark nito. Ibig sabihin, isa lang given. Paano itong Pmax naman? Wala naman thickness dyan. So ganito yun guys. Since kulang ang F1 dito, we can transform this equation into Pmax cross multiply times D times B divided by 2 is equal to F1. That we can insert here on the maximum tensile stress. Yan, tinuturuan ko na kayo mag-derive. So, pasok mo dyan. ST is equal to Pmax times diameter times width divided by 2 all over thickness and width. And your width should be cancelled. Kaya nga walang given na width yan. And in that way, given si ST as the 4 megapascals, given din si Pmax as the 0.05 megapascals. And we have the diameter of 500 mm. And diba, all over 2T. Which is cancel si megapascals, matitira mm. So our answer should be in mm. So guys, this is another formula na pwede nyong ilista. Pmax times D over 2T. Sulat natin dito. So P max times D over 2T. So that will become 4 times 2 divide 0.05 divide 500. Teka, no. 0.05 times 500 divide 2 divide 4. So that will become 3.125 mm. Alright. So, ang sagot ay yun B. 3.12 mm. So, naka-apat na questions answered na tayo, guys. So, buti naman lumalabas sa tanong lahat ng sagot. Ay, sa choices rather. Lastly, ilan na lang ba? Ayun, may 7. Hanggang 7 pala ito, no? Pagod. It's okay. As long na nakakatulong ako. So, differential band brake. A differential band brake has an operating lever 23 cm long. The ends of the brake are attached so that their operating arms are 28 and 150 millimeter long as shown. So may figure tayo dyan. The brake drum diameter is 61 cm. The arc of contact is 300 degrees. And the band is 102 by 3 mm. Coefficient of friction is 0.22 if the band is subjected to a maximum pressure 0.55 megapascals. Determine the braking force required at the end of the operating lever. So that the setup is a differential band brake. So walang tension or walang band na naka-attach sa pivot. So this is your pivot. Sabi natin 0.0. Of course, itong dulo yan lagi ang minimum the braking force rather represented by the FB. So how about these distances? So ang sabi, operating lever of 23 cm long. The ends of the brake are attached so that the operating arms is 28. So lagi yan, ito yung maiksi. 28 mm and 152 meters. So this is 152 millimeter, not meters. And the brake diameter is 61 cm. So gawin na nating millimeter. So that will multiply by 10. Because 10 mm is 1 cm. The arc of contact. So drawing na natin dyan, guys. So the arc of contact is 300 degrees. Burayin natin. Pangit. Mukhang 30 degrees lang. Pero sa picture, yeah. 300 degrees. So the band is 102 by 3. So, pwede natin sabihin na band width yan. Thickness is 3 mm. And the coefficient of friction is 0.22. So, dito ko na nilagay sa square na to kasi hanggat nakapula dito yung ink. If the band is subjected to a maximum pressure of sa band is 0.55 megapascals. Determine the braking force required. So, ito yung braking force. So, how about this distance? Kasi importante ito. So, ang sabi, as an operating lever, 23 cm long. So, ito yun. So, kabit na natin agad as mm. So, multiply by 10. So, that was 230. Meaning, from here to here. So, that was 152 plus 230. So, that was 382. Mula dito at mula doon. 382 yan. Yan. So, kompleto na tayo ng given, guys. So, palit na tayo ng dilaw. So, wala tayong kakampi ang kandidato rito, guys. Lahat ng kulay ginamit ko. So, okay. Yay. So, ang hinahanap is FB. So, kagaya kanina, nag-drawing muna tayo ng free body diagram. So, sabi sa inyo, wag natin kabisaduhin ito. So, let us assume that this is the clockwise approach. Wala namang sinabi, no? So, clockwise approach nga. So, pwede natin gawin ganyan na lang. At ganyan. So, this is your 0.0. So, this is your 28. Mukhang 28, guys. Parang wala pa akong 28 din, ha? So, this is your 152. Okay. So, ibig sabihin, ito yung F1 mo. Ito yung F2 mo. And this is your FB. And yung distance nun should be 382. Okay. So, pwede na tayong mag-moment of O. So, pwede nating sabihin na F1 times 28. So, ang magka-partner is F1 and FB kasi pareho silang pag ganun, papuntang O. So, that was 382 at itong F2 kasi is pag ganun. So, that was equal to F2 times 152. Okay. So, in order for us to get the FB, we need to get first the F1 and F2. Sa kagaya ng ginawa natin for the previous question, ginamit natin ang power tsaka yung coefficient of friction. So we can use the coefficient of friction, yung band tension ratio of EF theta. And we can get another relationship. Ang problema guys, wala namang F1 kasi walang given na power, wala ka rin makukuha ng torque. So, X na yan. So, saan tayo pwedeng kumuha? Remember guys that we have the Pmax as the maximum pressure of the band. So, that was 2F1 over diameter times width. And we can get that 0.55 is equal to 2F1 times diameter, which is 610 times the 102. So our F1 should be 0.55 times 610 times 102 divide 2. So that was 17,110.5 newtons. So pwede natin gamitin to. So mali pala yung sinabi ko na hindi gagamitin ito. Kumbaga, you can use this by using this Pmax. But you can use this as partner with the torque kasi wala namang given na power in order for us to acquire the torque. Ayan. Ayan. So, F1, pwede natin siyang kuhain, F1 over F2. So, that will become 17,110.5 over F2 is equal to F theta. F is 0.22 times 300 degrees times pi over 180. So our F2 should be 0.22 times 300 times pi divide 180. 0.22 times 300 times pi divide 180 e raised to, so that will become 3.164. Lagay ko na rin dito as your reference. So 17,110.5 divide answer. We have F2 of 5,407.43 newtons. Okay, so meron tayong F1 and F2 here. So we can get the FB as, so F1 is 17,110.5 times 28 minus F2, which is 5,407.43 times 152. Tama ba? F2 152, F3 82. F1 is 28. So masyado malaki si F1. Hindi, tama si F1. So that will be ulit 17,110.5 times 28 is 5,407.43 times 152. Unahin muna si F2. Tama. Unahin muna natin si F2 at this side. So that was 5,407.43 times 152 minus 17,110.5 times 28 over all divided by 382. So we have this FB as 897.5 Newton. Okay, so ang FB natin ay 898 Newton kapag ni-round up. Okay, so nakalimang question na tayo guys. So proceed tayo for the last two. Determine also the torque applied to the brake shaft. So pwede nating sabihin torque is equal to F1 minus F2 times diameter over 2. So alalahanin lang natin, balikan lang natin slide na ni F1 and F2. So ang F1 natin is 17,110.5 minus F2 is 5,407.43 newtons times diameter ay 610 over 2, which is an mm. So the answer is 17,110.5 minus 5,407.43 times 610 divide 2. So that was 3,569,436.35 Newton mm. And we all know that 1 kilonewton meter is equal to 1 million Newton mm. So just divide it by 10 raised to 6. So that will become 3.569 kilonewton meter. So that was letter A, obviously. Okay, lastly, double block naman tayo. Na double block brake assembly, calculate the friction power of the 500 mm drum rotates at 160 RPM at the instant the braking force is applied. The coefficient of friction is 0.28, contact angle on each block is 90 degrees, and the normal forces on the left and the right blocks are 600 Newton and 800 Newton respectively. So hindi ko na i-drawing yung pinaka-assembly. So tingin ko pwede na yung drum diameter tsaka yung two pairs of the normal force and the frictional force. So dito, left, syempre may normal force dyan. And of course, may kumukontrang friction, FL. At dito naman may normal force right at may kumukontrang right frictional force. And of course, we have this drum diameter at sabi 500 mm. Rotating at 160 RPM. The instant the braking force applied. The coefficient of friction is 0.28. Walang sinabi kung left or right, meaning parehas yan. Meaning parehas. So that will become FL is equal to FR. Contact angles. Pag sinabing contact angle, guys, 2 theta agad yan. As I said earlier, meaning your theta is 45 degrees. At walang sinabi kung left and right siya. So meaning it is equal to left and right. And the normal forces on the left, ang sabi is 600. At ang normal forces daw sa right is 800. So determine the friction power. So in order for us to get the friction power, we all know that the power is equal to torque multiplied by the speed divided by some constant. And mayroon na tayong N which is 160 RPM. Ito siya. So we are going to get the torque, and in double block brake assembly scenario, we all know that torque is equal to frictional left and frictional right force times diameter over 2. So we need to get these two. And we all know that the formula for that is equal to F is equal to normal force times coefficient of friction and some constants of 4 sine theta divided by 2 theta plus sine 2 theta. And kapag left, gawin mo lang left lahat yan. And syempre kapag right, gawin mo lang R lahat yan. Okay? So, ang sinasabi ko kanina guys, minsan talaga binibigay is parehas yung friction, coefficient of friction at both sides, and contact angle. Of course, dito lang magkakaiba sa normal force. Na syempre siguro depende sa bigat na sinasalo ng drum sa block. But we can simplify this. Since parehas ang coefficient of friction, pati na rin itong loob na to kasi parehas ang angle of contact, which is the 45 degrees. So we may say that the torque is PL plus PR. PL plus PR. PL plus PR, which is F na lang ilabas natin. And of course, this 4 sine theta to theta plus sine to theta. And overall, we have torque is equal to 600 plus 800. Frictional force muna. So, torque na natin to. So, times diameter over 2. Kalimutan ko to. So, times diameter over 2. So, that will become newtons ito. And mm yung diameter mo. So, that will become newton mm times F, which is 0.28 times. Mukhang hindi magkakasya to. Pwedeng natin 4 sine 45 degrees guys, not 90. So mahaba ito tingin ko. But kasi may logo pa ako dyan. Char. So, ibay na lang natin ng lugar itong 2 theta. So, ang 2 theta natin is, lagyan natin na siguro dito guys. Burahin ko na to guys. Kaya importante sa inyo yung nagna-notes, wag lang nanonood. Because note takers are history maker. Okay, so that was 2 theta. Ibig sabihin 90 degrees. Convert natin sa radians. So that was pi over 2. Pi over 2 na lang lagay natin. Plus sine 90 times diameter over 2, which is 500 over 2. So our torque will be 4 sine 45, 0.5 pi plus sine 90 times 0.28 times 600 plus 800 times 1,4 times 500 divide 2. So that was 107,821.01 Newton mm. And if we're going to substitute here, I need some space. Ayan, I need some space. Skurin na rin natin to. Ayan. Ito yung tinatawag na blackboard kasi blocking screen. Sure. And so we have a torque here, and we all know that in order to acquire power in kilowatts, our torque should be in Newton mm. So that was 107,821.01 Newton mm, and our speed should be in RPM. So that was 160 divided by constants, which is 9.549 times 10 raised to 6. So our power should be in kilowatts. So that was yung nakuha mong torque kanina, multiply mo ng 160 and divided by 9.549 times 10 raised to 6. So the power is 1.8. Ayan, 0.66 kilowatts. So the answer is, ayan, letter C, 1.81 kilowatts rounded off. So ayun guys, marami tayong nasolve na problem for the brakes at medyo matagal talaga to guys kasi kailangan to isa-isang ina-explain, pero I hope marami kayong natutunan. So continue to support my channel guys by subscribing and sharing this video. And of course, we have our separate Facebook page on the link given. So guys, thank you ulit sa pakikinig. I hope marami kayong natutunan. See you on our next videos. Bye-bye and God bless.